afternoon. It's not morning. We're starting about 45 minutes late. I hope you all are patient. Can you hear me okay? Okay. I'll go through briefly some introductions. Myself, I'm William Bridges. I'm from Process Improvement Institute. I'm a chemical engineer by trade, bachelor, master's, chemie. 45 years experience, and been working in the Middle East for 25 years. Spent a cumulative 10 or 11 years here now, so I'm here a lot. I work with most of the companies in Saudi and in Bahrain and in Qatar. Not too much in UAE. So I'm here to moderate this speech on this panel, on risk-based inspection with the aging facilities. We have three good folks here. I'm going to let them introduce themselves because I thought somebody else was going to introduce them, so I'm not quite prepared. So just a very brief, gentlemen, each one. I think you have microphones. Ali, can you go first?
Thank you, William. Assalamu alaikum. Good afternoon, everyone. I am Ali Al-Garni, maintenance manager from Saudi Arabia.
Hisham Smith, process safety lead in R&D.
And Isam Virgil, QHSE manager with Fujairah Oil Zone.
Thank you, gentlemen. Could you go to the next slide? There you go. Just thought I'd have one introduction slide for the topic to kind of place it into perspective. There's been a few papers on risk-based inspection and aging facilities already, and this is a panel discussion as well, but I think it's good to put it into perspective. 80% of major process safety accidents, I'm not talking about occupational safety, I'm not talking slips, trips, falls, and working at elevation, etc. I'm talking about process safety. 80% of those accidents happen during startup, shutdown, online maintenance. Okay, those three modes, they're very batch type of modes, and that's where most of the human error is. And we haven't done a good job as an industry of analyzing and preventing those accidents. 20% of the major accidents happen during normal mode of operation. And 80% of those is due to issues with inspection, corrosion, erosion, and other factors, materials of construction. So we're dealing with, in this panel, events that cause about 16% or so of the major process accidents. We typically, as an industry, do a pretty good job on this. The problems we're having now is the aging facilities. We have some old facilities in the Middle East and some very old facilities elsewhere. We're all dealing with this problem, so this should be a very good panel discussion. I could have the next slide, please. The next one, please. One more. One more. Click. Okay, so we're going to go through a set of questions that we think are important. We've had some discussions with others outside of the conference and in the conference. And we'll ask each of the panelists to comment on this for maybe 2 or 3 minutes, and then we'll go to another question, and then we'll see if we have time for questions from the audience and handle it the same way. So the first question I have for everybody, and we'll start with Ali since he's the first, and the next time we'll start with Hisham, and the next time we'll start with Isam. What's the biggest issues that at your facilities you guys face with the aging equipment and even aging civil support equipment like structures in relation to risk-based inspection?
Okay, let me first start with reflecting on what has been highlighted and presented today by Mr. Hisham and Mr. Abdul Fadl and Abu Aziz. They covered a very critical subject, and Mr. Hisham, especially his presentation, was about the aging facilities. I believe what I'm going to say is a reflection just to what they have presented. To me, and from my experience I see the biggest issues any facility or aging equipment is facing is the repetitive failures, either from rotating equipment or from the static equipment. For example, in this rotating equipment, if we look at the pumps, compressors, and turbines, in the aging equipment, you will have interruptions in the operations or productions also will have impact on the safety of the facility if you have these repetitive failures. And the static equipment, and specifically I would say the piping, the most challenge is the corrosion. The corrosion issue is spreading and growing rapidly once it starts with you, and this is happening almost most of the time in the aging facilities. These two, I would say, issues, the corrosions and the repetitive failures, are having a challenge and risk in the facility when it comes to safety and on the people and on the facility. The second thing, the biggest issues, is the spare parts obsolescence. If you have spare parts for equipment and you need to repair it and return it back to the surface, but your team was searching for these spare parts and did not find it, and you end up by finding out this the supplier of this spare parts has closed out because this is aging equipment, and you need to find out another supplier to provide this, or maybe you need to replace the whole equipment because no one else is still supplying the spare parts of this material. These two things will impact the operations, as I said, and the safety, because they are expected always in the aging facilities. This is what I have to highlight about the issues of the aging facilities.
Thank you, Ali. Now, Mr. Hisham, same question.
Thank you, Ali. Just to also elaborate more on this as aging facilities. Now, Ali highlight critical actually point related to the spare part. And really, with the time, after 30 years or 30 years plus, you will find that spare part is obsolete, even if it is for a critical equipment or a safeguard. Let's talk about the process safety, a safeguard as an equipment. So now, this is really a big challenge that lead the organization to go for retroactively redesign the equipment. And now, that is another critical area where the organization need to face. Are they willing to go for redesigning or run with an equipment that doesn't have spare parts? Vendors declare it, sorry, this old model doesn't exist anymore, and even the new model, you need an MOC definitely based on the organization system, and that could be the new model impact the existing process when it comes to the setup and layout, etc. So this is actually very critical I'd say, concern, and nowadays start becoming a common theme among those organizations what we need to do from strategic plan. Interim mitigation, you cannot live with it for a long time. At the end, it's an interim. Whether you are operating the unit with a low load or moderate load, just to avoid the deteriorating of that critical parts. For 1 year it could be, or less than a year, but at the end you will face the fact that you have to replace it or mothball it, where the business will interrupt, of course, interfere, saying, no, there is a business need, you cannot just mothball this process as the product is very profitable. And that is really, I would say, the corner where the executive layers within that organization will be. And as a critical layer driven by the safety, they have to comply or they have to face down the road the music, which is, God forbid, the red zone of that matrix from reliability or from process safety. And no one would like to run with a hazard. Thank you.
If I could just add one more point to this. A similar problem we face, and you were mentioning sometimes meeting the challenge of upgrading the equipment because now of the age and there's no replacement, there's no documentation. We're also running into a similar issue in that we're we're debottlenecking many of our processes over the same period of time that they're aging. And so now you get this complicating effect that we're running outside of capacity in some cases, like on level transmitters for knockout pots and other things like that. So it's a good opportunity to look at everything when you start doing these obsolescence evaluations that we'll talk about here in a few minutes. But if you combine that with the debottlenecking we're doing, it makes it even more urgent to look at, do we really want to keep running with what we have? And it's a valid question. Now, Mr. Asim.
Thank you very much, gentlemen. I think you've said it all, but I just want to mention something about because when we talk about aging facilities, and probably one of the most important issues that companies are facing today is that their equipment are not designed for the current conditions. And an example of that is when we talk about upstream facilities, and especially here in the Middle East and North America, like these facilities were designed 30 years, 40 years ago, and as you know, probably if you came from upstream background, you know, at the beginning or the early stage of the reservoir, basically the production is naturally, or the wells are producing naturally. Then as the reservoir gets depleted, we need to come up with some artificial lift systems, and one of them is water injection. So basically what we are doing, we are just changing the operating parameters of the feedstock or petroleum products that facilities is handling. So if a facility starts or was designed to handle 20% water, and now the wells are producing 40%, so then that's a challenge, not only from the operating perspective, but from the integrity perspective, such as corrosions, and it's the same thing, like there are facilities that they were designed to 5% H2S, but the field now is producing, the concentrations is 20%. So that's the challenge for the companies now, to how to make sure to upgrade those facilities to handle the new conditions. But on the equipment side, probably especially static equipment, there are options, like you can coat your equipment or do something, but probably one of the biggest challenges when it comes to automation, the hardwares and the softwares, especially in the cases where you cannot upgrade your systems or the systems are obsolete. So that's what put like organizations in a hot spot, and they need to think their way how to develop more effective integrity or asset integrity management program if they want to keep running this equipment.
Thank you. If we could have the next bullet, please. The next question is, assume you have a risk-based inspection program, but you don't have an obsolescence plan or program of when you're going to retire, replace. How do you merge those two together? How do you first implement an obsolescence program, which is necessary for aging facilities, and how do you merge that in with the rest of your inspection program? And this time I'll start with Hasham, and then we'll end with
Thank you, William. Any risk-based plan should consist first the plant screening. So, and this goes hand to hand with the risk assessment and management itself. So the RBI, I would say, the right hand and the left hand is the risk assessment hand. So what we'll do, the radar as a risk assessment will do the site screening, identifying the critical areas, and hand it over to the RBI system as a second step. Now, the RBI will do, based on that screening, select the critical, from the critical area, those safeguard, and consider them as one layer as a critical equipment. Now, the RBI will extract those equipment for another reliability assessment based on their matrix to define how supercritical is that area based on the consequence, whether from HSC or financial impact. Then it will come the priority 1, priority 2 from RBI. And accordingly, the strategic plan for spare part and the PM frequency will be developed and enrolled for the PM schedule or plan, considering the last or the fourth plan having the right equipment or tools as a technology, as a best practice to ensure that PM for those critical equipment is done effectively, efficiently, and by the right qualified team. So it's a start by risk assessment and end up handover to run the rest of this plan by the reliability group owning the RBI. Now, yet the RBI, within their assessment, they have another layer called reliability-based reduction objective for those supercritical equipment. And this is, in my experience and limited experience, of course, with the reliability, this is the practice, or I hope it's a good practice, how to set the plan within the safety management boundary itself. Thank you.
Thank you. Ayman?
Thank you very much, Hisham. I think when we talk about obsolescence, it's a fact. So basically, when we buy new equipment or we design new plant, we know it will not run forever. At some point, we have to proceed with the commissioning of this plant. But it's very important that we manage the life cycle of the assets. And how we do that, like basically our risk-based inspection programs is one of the things that we should consider if we want to delay this obsolescence without compromising safety. And when it comes to the risk-based inspection programs, basically it's not different than a risk assessment. It goes through the same step, the same process. It just you are targeting basically the risk of equipment failures. So it's not different. So when we talk about, like if you go to API, the 580 and the 581, basically they are very well aligned and matched with the ISO, the framework of the risk management. So it's not different.
Thank you. Now, Ali, and especially on the obsolescence plan and integrating with that.
Okay. Just to add, one of the practices we used for the obsolescence, and this is what asset management team and the reliability team are doing, is the obsolescence revalidation. We know that every equipment spare parts are going to be obsolete with the time. So the practice and our reliability team are doing this annually is to revalidate the obsolescence of the spare parts. They issue annual assessment for these revalidation spare parts, and you will know from this revalidation assessment which spare parts will be obsolete and when. So you will know that ahead of the time which parts will be obsolete, and you can be prepared for the alternatives. In addition, this can be integrated and combined with the RBI, because the RBI will tell you, as the gentleman said, will tell you what is the degree of risk that you have in your facility, and you know where to focus in your maintenance programs and special inspection programs, and this will be followed by the budgeting, planning, and whatever investment you need to put in this facility to make it running and operating safely.
Good, thank you. Just one point before we move on to the third question here. When we first developed LOPA, Layer of Protection Analysis, it was a way to be able to communicate to each other as much as analyze risk of what is our critical safeguards and what's our critical causes that would start an accident sequence. And one of the first books they asked us to develop immediately after that was a guideline book for initiating events and for independent protection layers, so that everybody in the industry would have a basic standard to go back to that would tell you if you do this, 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 you should get this performance out of that piece of equipment. And here's how you collect data over time to make sure that is actually working for you. And that book was published in 2015. It has obsolescence built into it a little bit, but that comes from if you're not able to maintain your probability of failing on demand for a certain active component, or if your failure rate is going up, or your predicted failure rate of fixed equipment or pumps or other things are also going up. What do you have to do to keep that initiate event frequency in line as well? So there really is a way to tie all of that back together. It's not complicated, but it's a lot of work, and you can tie it all back into your obsolescence plan as well. Next question. Thank you. So just looking ahead a little bit with the advancement of AI, let's say, but at least digitalization, I'll never get that word right. Where do you see this going in respect to hopefully helping to keep track of everything in RBI a little bit better? And Mr. Asom, I'll start with you first.
I think from perspective of the new technologies, I want to make something clear that introducing AI or digitalization will not change the process. The process stays the same. So the steps that you need to follow to have or to perform an effective RBI stays the same. What the digitalization or the AI will help us with more capabilities for analytics. And probably it help us to get better outcomes from our exercise, but it comes back to the data because we develop the algorithms, we develop the models, and we fit the models with the data. If the data is not good, basically, what do you expect from the model or from the AI to give you? So the basics will not change. Definitely, there is a big opportunity if we do it properly. And it comes back to the call of the company from this exercise. If they want really to implement the AI or the digitalization or automating the processes to really improve the performance and get a better outcome, definitely the change and the outcome will be significantly higher. But at the end of the day, the better the data you put in, or the better your model will be. And it comes back also to training. Training are the people that they are working on and qualified. Do they understand the goal? Do they understand the process, how to do it? Those are all the things that you need to take into consideration if you want to automate or you want to digitalize your RBI.
Thank you. Ali, same question.
Okay. First, I would like to say the RBI is relying on the inputs from the process parameters and the inspection readings, such as the OSI and other inspection programs. So the accuracy of the RBI results relying on the accuracy of the inputs coming from the team. But this is very important to have the software of the RBI running smoothly and give you the right results. But these days we started to see the prediction and conditional monitoring tools and systems which give you live monitoring on the assets all the time. And instead of having the RBI every 5 years or whatever interval is being conducted in each organization, you will have live monitoring on the assets all the time. And these now solutions coming in the market, and many companies are maybe started using these options and solutions. They could be support or help for the RBI. Maybe some of them could replace the RBI with these live tracking and live monitoring solutions in the market. So I see there is promising solutions in the market, and I have seen some trials and pilots of these solutions in rotating equipment. And these can give you a model of when your equipment could fail. And this is the life cycle expected for this equipment based on the inputs you have. And this equipment or this pipe or this vessel could stay with you for this life cycle. So I think also the RBI can be integrated with these solutions to come up with something better and help the facility to stay longer cycle.
Yes, I think for corrosion, erosion, those kind of effects, it has a very good place. For the relief valve testing and other things, I think we're still stuck with having to do the test. I think you still need to comment, Hisham. So your turn.
Thank you. I'm not expert in RBI, honestly. However, definitely, in order to be a good process safety, you need to have the fundamentals of the RBI. However, when it comes to process safety, we are so cautious when we speak about digitalization, because we are a strong belief that outsourcing the safety knowledge is a risk by itself. Now, we understand digitalization is coming, and it's almost like a brand for a few years ago, and the future is there. But when it comes to process safety, you cannot outsource or delegate a robot to analyze and develop your risk scenario. Why is that? As far as we have an SMS, what's so called, an SMS, incident investigation, that is where we count on to tell us what went wrong and what was the issue with our engineering standard, where we develop and design and construct our facility. And accordingly, that element usually retroactively revisit the engineering standard for the best safe approach where we need to comply with. Now, if I leave the digitalization to take the lead for this, I need to have a control on that piece of equipment, whatever, but shall not be left controlling me or my decision. That piece of equipment need to be revisited from time to time to get updated, software, whatever. Why? As far as there is an incident investigation, that's where we count on to update our engineering standard, best practice, philosophy, and JED. So we don't outsourcing our thinking when it comes to process safety to a certain equipment or software. We do have, for example, BHA application, but it will not take the full role of the hazard leader, for example. Definitely. So that's my thank you.
Okay, thank you. That was the prepared questions we have. I don't know, do you have any time for questions from the floor? I'm checking first to see if we have time, because I know we started late. Should we? Or? Yes, okay. So we'll do at least one question. Let me just make one more point about risk-based inspection and inspection and data, and big data in general. I'll give you a case study that involves two plants, one in UAE and one in Saudi Arabia. And I was looking at their relief valve data, inspection data. And in both cases, this is a bad example, by the way, but in both cases, they showed their failure rate of a relief valve was 25%, based on inspection test data from pop test. So what should the reliability of a relief valve be on a pop test? Group? Anybody? What's the target reliability in risk-based inspection for a relief valve inspection? Or you can think about it like as an independent protection layer, what's its probability of failing during a test? What should that be maximum? 1 in 100. That should be 1 in 100 is the typical target we set in our risk assessment. That's how much credit we give that device. So it better be hitting that or we're in trouble. 25% is 25 times too high, right? So my first impression at both companies was, you're not looking at your data because it's impossible to have a 25% failure rate. So I went back and looked at how they were just entering their data into their software tracking system and how they were analyzing that, and they just didn't really know what they were doing. So by the time we re-looked at the data, one company was in compliance, they were at 1%, one company was at 4%. But they didn't even know the answer. That was the most disturbing thing. You know, if you're going to get this data, you have to use this data to make real-time decisions. And the company that had a 4% failure rate, 4 out of 100, to get to 1 out of 100, they shortened their turnaround and inspection timing from 4 years down to 3 years. And then for the next 3 cycles, I happened to be there as well. It was 1 in 100, 1 in 100, 1 in 100. So you have to really look at your data, and sometimes you'll be surprised when you look at it how bad it is, and then you'll start to find out you're just not looking at your data enough or looking at it right, because you're probably not that bad. Anyway, just thought I'd throw in the other side of it. So question, I saw 2 hands up over here. Okay, this guy has the mic first.
All right. Thank you for the presentations and the explanations, answers to the questions. I'd like to ask a question from the offshore part of the industry. RBI has been extensively used downstream, petrochemicals, chemicals, and oil and gas. But I'd like to ask the question for the aging of facilities from the major accident hazard perspective and the identification and management of safety critical equipment and systems. Because for that, you don't just have, for example, reliability. You have the functionality, availability, reliability, survivability, interdependability, all these aspects that have to be in place against performance standards that have to be maintained, and it's becoming a challenge, or will become a challenge, for aging facilities.
Anybody want to take that question? It's the same questions, only applied to offshore. Yeah.
Yeah.
Yeah, mainly
Mainly offshore, because in the UK, for example, for those who know the KP initiatives, KP4 is on aging of facilities.
Right.
I didn't have time to ask the question earlier, but the same principles. To do a coma report or safety case report, the contents are more or less very simple.
But in some countries, like in Saudi, it's onshore more than offshore because the production is more onshore. Same in North America and South America. 95% of our production is onshore. Those facilities are aging too, so it's the same
We have
question.
a lot of stuff in Gulf of Mexico.
Yeah, that's right.
Saudi has a lot of, have the biggest offshore field actually. Yeah. Now, the question is about
What's the question?
I will repeat.
The question, I'm not sure, but I thought it was, how does these same issues apply to aging facilities offshore?
I
under control.
rephrase, it's better to rephrase.
Okay, rephrase.
Major accident hazards
Right.
are what we are trying to avoid. And the risk-based approach is the Pareto rule, focused on 20% of the equipment and systems that bring you 80% of the issues. That's essentially the concept upon which the risk-based approach is based. So for this one, how are you dealing with the major accident hazards in terms that are beyond just the RBI? RBI inspection is just one component, because when you deliver new facilities, you are supposed to deliver them to be, for example, availability, reliability. You have your parameters in the performance standards, and you have to demonstrate them when you are commissioning, starting up, and then throughout the life cycle. That was my question.
I think if you want to look at it from a bigger picture, basically you are trying to manage the risk, right? And in what perspective you put it?
Major accident hazard is the core topic.
Yes. Why major incident happened? So when we get to the root cause, that's the learning, that's where we should start. And we should take all this learning into developing and designing our RBI program to prevent similar incidents from happening in the future. Now it comes back to how good we are in doing that, how effective in really assessing the risk and learning from previous incident. That's the question I would ask. Because if you go, like all these companies, and I worked for at least 4 major operators, they all have risk management, or they have risk inspection or asset integrity management programs. But like the effectiveness, how we can measure that? Like, is it the effectiveness, is it by having an incident, or we have a program that is based on continuous improvement, that has the support from the top management?
My question, sorry, Mr. Aysam, my question was not
If
there.
we're dealing with major accident hazards,
Yeah.
I think it's good for this group to put that into context. That's a British terminology that's not used by everybody
Performance
here.
standards.
But if we're trying to control the risk of major accidents, our risk assessments, being done in this area, identify what all those scenarios are. We know what our initiating events are. We know what our independent protection layers are for any type of active type of accidents. The ones that are due to corrosion erosion are the ones I think that we're being a little weaker on for continuous mode of operation. So that has to do with risk-based inspection. I've seen it applied the same way offshore with aging facilities and onshore with aging facilities. I haven't seen a big difference myself. But
I don't think the term safety critical equipment and system is typically British. It's across the industry. Identification of safety critical equipment and systems
that's
is
a good terminology now.
And a key deliverable of any project. And the question is about the performance standards of those safety critical equipments and systems. Some countries they call them HSECES, but mostly it's SCES. So these systems and equipment, what I meant, RBI is just one part. The bigger picture for the risk-based approach is much bigger than that. That was the purpose of my question.
I think that comment is well placed. RBI is only a small part of everything, and if you apply it to most of the fixed equipment and assets, including the civil engineering aspects, we still have some weaknesses, but I think we're getting a lot better as an industry, and I think some of the topics we discussed here are helping. As far as maintaining our critical items, such as check valves, safety instrumented systems, DCS instrumented systems, relief valves, all the active devices that are serving as independent protection layers, we have standards for that now. We didn't have those 15 years ago. We have them now. And I think people are beginning to follow them, but I think the databases that we have for inspection and maintenance are probably good enough, but we're just not using them well enough now. That's kind of my overall view of those things. Okay, I think we're probably out of time. But anyway, thanks for your question. Sorry we didn't get to your question. If you want to catch us at a break or after in the booth, that'd be fine. Just one more comment. I'm casual and not on purpose. My bags are still in transit from 2 days ago. So they just now landed in Paris, and maybe they'll be here tonight. So I just wanted to apologize for coming across a little too casual.